Aloha BIOCHEM. In this video we continue in Chapter 2 and discuss atomic structure. So this time we cover section 2.2, atomic structure. We take a look inside the atom at the subatomic particles, and we see what makes an atom of one type different than an atom of another type. So why do we call certain atoms carbon atoms and other ones oxygen atoms, for instance? First, let's recall what we did in our previous lecture when we compared elements and atoms. Elements are the simple substances that matter is composed of, and which all matter can eventually be broken down into. Elements don't like to change their identity, you cannot just change a chunk of iron into gold, or you can't just change copper into silver or carbon into oxygen. They don't do that. But under certain very special circumstances, it can happen to certain elements. It's very rare, and however, there are instances where it does happen, and there are even medical applications for such nuclear processes. So we will discuss nuclear chemistry at a later point in the semester. But for the most part, elements don't do that. We know of 118 different elements. So atoms are the tiny particles that make up an element. You see, an element is a substance. It's a large substance which you can put your hands on. You can observe its properties and such. So an atom, on the other hand, is a tiny particle that's too small to see, but it's what makes up this element. So if you take a certain element, like maybe a chunk of iron, and you cut it in half and you have a smaller chunk of iron, and then you cut that in half for an even smaller chunk. And if you keep on doing that, eventually you'll get to a tiniest piece of iron, and that's an iron atom. And if you cut that iron atom in half, it's no longer iron. So an iron atom is the smallest particle of the element iron. And likewise, a carbon atom is the smallest piece of carbon. The reason elements don't change their identity is because their atoms don't change their identity. So carbon atoms don't just convert into nitrogen atoms. There are 118 different elements because there are 118 different types of atoms. It's pretty interesting that atoms were discovered much later than elements, though they were hypothesized to exist for a long period of time. So people thought about the existence of atoms for thousands of years, but enough evidence wasn't gathered to really say that yes, atoms are real until the 1900s. And that, evidence, was gathered much later than, the elements were well established. So what is inside of an atom? What does make carbon atoms different than oxygen atoms? It's the subatomic particles. Atoms are made of protons, neutrons, and electrons. And the reason a carbon atom is different than an oxygen atom is because it contains different numbers of these particles. These three particles are different from one another, and we can distinguish them by these following properties: the mass and charge. The protons and neutrons are much heavier than the electrons, and if you compare their masses in grams, it's kind of difficult to do because they're so light. Protons and neutrons are both approximately the same mass, on the order of 10 to the minus 24 grams, and electrons are much lighter. They're on the order of 10 to the minus 28 grams. But we don't really use grams when we're talking about particles this small. If you convert these masses to atomic mass units using the following conversion factor, then you see that protons and neutrons are roughly the same weight. Neutrons are slightly heavier than protons, but they're both about 1 atomic mass unit. Electrons are almost insignificant compared to the mass of protons and neutrons. So electrons are, you can basically ignore their mass. They're so light. In addition to the mass, there's another property called charge. Protons have a positive charge and electrons have a negative charge of equal magnitude. So the charge of the proton is opposite to that of the electron. Neutrons do not have a charge. What charge is can be explained by the diagram in your textbook. If you have two protons, they will repel each other. Two positive charges repel. And two electrons would also repel each other, but opposite charges attract. Protons attract electrons. And this force of attraction is what holds atoms together. You see, atoms are composed of all three types of particles, and the opposite charge between protons and electrons helps hold an atom together. As an example, let's look at a lithium atom. Here is a model of a lithium atom, and there are, in this model, 3 positive protons right there, 4 neutrons right there, 1, 2, 3, 4, and 3 electrons out there. Now, I've highlighted the protons because it's the protons that identify this as a lithium atom. Anything with 3 protons we call lithium, and all lithium atoms have 3 protons. It's what distinguishes different types of atoms. So that's it right there. The reason atoms are different from one another, so the reason a carbon atom is different from an oxygen atom is because they contain different numbers of protons. So that's it. But there are other subatomic particles in there, and they do play a role. Now, the atom is roughly spherical. The protons and the neutrons, the heavy particles, remember these are the heavy ones, are located in the nucleus of the atom. So the very center of the atom is a region called the nucleus, which contains the protons and neutrons. The much larger electron cloud surrounds the nucleus. The electron cloud is another name for the region of space that the electrons buzz around in. The electrons don't really orbit the nucleus. They're kind of just buzzing around, in fact, popping in and out of existence. This one might disappear and pop back up over there. And electrons have weird behavior. But if you watch them over the course of a period of time, you see that they occupy a spherical region around the nucleus. Now, because this atom has 3 positive protons and 3 negative electrons, we say that it's a neutral atom. So 3 minus 3 equals 0. So this one is neutral. It does not have a net charge. The number of protons inside this atom is given a special name. It's called the atomic number. So the atomic number, which is represented by the capital letter Z in your textbook, although I won't be using this symbol too much, the atomic number is just another name for the number of protons. So the atomic number of lithium is 3. Now, you can also find the atomic number on the periodic table where lithium is located. So here is the box of lithium. You'll find a similar box on the periodic table, and you see this is lithium. That's the symbol for lithium, and there is the 3. The lithium is element number 3. That's the atomic number of lithium, the number of protons that all lithium atoms have. Now, usually on the periodic table, there's another number called the atomic mass, and that tells us how heavy a lithium atom is. And we'll talk about that later, but just keep that in mind. Let's find lithium on the periodic table. Let's pop it up So here is the periodic table. The first element is element number 1, hydrogen, and you go over across, there's element number 2, helium, and then in the next row there's element number 3, lithium. And so if we zoom in on lithium, so there it is. You see the information inside this box is kind of looks a little different. You know, they had the atomic number over here to the top left and the atomic mass is to the top right, and that's okay. But you see lithium is element number 3, atomic number 3. So all lithium atoms have 3 protons. And if you want to know how many protons atoms of carbon have, you just find carbon. It's over here, it's element number 6. And so carbon atoms have 6 protons because carbon is atomic number 6. There's another special number that you should know about. It's called the mass number. And the mass number is basically the number of heavy particles in the nucleus of the atom. So how many heavy particles are there? So how many protons and neutrons are in there? That's what the mass number is. It's the number of protons plus the number of neutrons. And you can see that there are 3 protons plus 4 neutrons, so the mass number is 7. The mass number is represented by the capital letter A. And I won't be using these symbols too much myself, but if you see them in the textbook, that's what they're talking about. So again, to reiterate, the atomic number, which is the number of protons, determines the identity of the atom. Anything with 3 protons is a lithium atom, and anytime you have a lithium atom, that means it has 3 protons. So all lithium atoms have 3 protons, exclamation point. But here are a couple of interesting questions. Do all lithium atoms have 4 neutrons? We see that this one does. There are 4 neutrons. Do they all have 3 electrons? We see that this one does. Well, the answer to these 2 questions is pretty much no. You know, all lithium atoms have 3 protons, but the number of neutrons can vary in general for an atom. And the electrons, sometimes you can lose an electron, and sometimes you can gain an electron. So this lithium atom can lose one of its electrons. It can gain an extra electron. And we'll talk about those 2 situations later on, where atoms can have different numbers of neutrons, and they can gain or lose an electron or 2. So we'll talk about that later. Let's take a look at a few more examples. So here are the 4 most important elements on the periodic table in biochemistry: hydrogen, carbon, nitrogen, and oxygen. And you've probably located these, but I'll just point them out to you. So hydrogen is right here. It's element number 1. Okay, there it is. Carbon, nitrogen, and oxygen are all right next to each other. They're right there. 6, 7, and 8. Elements 6, 7, and 8. Okay, so those 4 elements we're going to learn an awful lot about this semester, and we're going to learn an awful lot about their atoms as well in this chapter. Now, here are some models of these atoms. So here is a model of a hydrogen atom, a carbon atom, a nitrogen atom, and an oxygen atom. And so the atoms kind of tell us a little bit about the element. So in the hydrogen atom, it's pretty interesting that there are no neutrons in hydrogen atoms. Most hydrogen atoms have 0 neutrons in them. They just have 1 proton and 1 electron. So 1, 0, 1, 1, 0, 1. So the mass number of this particular hydrogen atom that we see right here, remember the mass number is how many heavy particles, how many protons plus neutrons. Well, I see 1 proton plus 0 neutrons, so that's 1. The mass number is 1. Let's take a look at a representative carbon atom. So we can tell this is a carbon atom because carbon is element number 6, and I see 1, 2, 3, 4, 5, 6 protons in this atom right here. So this one has 6 protons. What about neutrons? Let's count them up. 1, 2, 3, 4, 5, 6 neutrons, and then 6 electrons. 1, 2, 3, 4, 5, 6. So 666. This is the evil atom. 666. But actually, all carbon atoms don't have 6 neutrons. Sometimes you'll find carbon atoms with 7, and we'll talk about that situation in our next video. But this one, we can see that there's 6 of each particle. So what is the mass number of this particular atom? How many protons plus neutrons? Well, if you take protons plus neutrons, you can see the mass number is 12. Here's a representative nitrogen atom. It's kind of an ugly looking atom, distorted. I didn't have a nice circle to draw it, but you get the picture. So how many protons, neutrons, and electrons? So you can count them up. Nitrogen is 7, atomic number 7, so there better be 7 protons in here, and you can see there are. And you can count them up. There are 7 neutrons and 7 electrons. You see, a lot of times the number of protons, neutrons, and electrons is equal, but not always. Not always. And in fact, most of the time it's not. But for these two examples, it is. And so the mass number for this atom's case is 7 plus 7 is 14. There are 14 heavy particles in the nucleus. Now here's an oxygen atom. Oxygen is element number 8, so there are 8 protons. And this one has 8 neutrons and also 8 surrounding electrons. So the mass number here is 16. You can see that all of these atoms that I've drawn here are neutral in charge because the protons equal the electrons. Okay, this one is neutral. They're all neutral. So neutral atoms always have equal protons and electrons. In the next chapter, we will talk about charged atoms which have different protons and electrons, and those are called ions. So, here is an oxygen atom, but if it gains an electron or 2, then it would become a negatively charged ion. And we'll talk about oxygen ions in the next chapter, chapter 3. So that's it for this video. In the next lecture, we'll discuss isotopes. Stay tuned for that. Aloha.